Hi students, welcome to our YouTube channel again. As our subscriber demand, today our topic of discussion is the Wittig alkene synthesis. In this topic, we are going to discuss what is Wittig alkene synthesis or about the definition of Wittig alkene synthesis. I am going to write the definition. And the second thing we are going to discuss that the formation of Wittig reagent formation of Wittig reagent, and the third step or the third thing we are going to discuss that is the mechanism of the Wittig alkene synthesis. Okay, so first of all, the definition, what is meant by Wittig alkene synthesis. As the name indicated, like the alkene synthesis, so it means it is the process in which we use the Wittig reagent to form alkene by the use of aldehyde or ketone. So it means here, according to the definition, there is like the formation of alkene, formation of alkene, formation of alkene for preparing the alkenes from aldehyde or ketone. Okay, by the use of Wittig reagent. Okay, let's suppose here I am going to write the Wittig I'm going to take like a general reaction aldehyde or ketone. They are going to treat with the Wittig reagent that is normally known as ylide. Okay, that will form alkene product, and along with the alkene product there is the another product normally that is known as triphenylphosphine oxide. Okay, so I am going to write like here byproduct in general. Okay, I will tell you in detail. So that is what about the general equation in which we can understand or we can easily define the Wittig alkene synthesis. Okay, now the question is, what is meant by ylide? Ylide is any compound like ylide is any compound with opposite charges on adjacent atoms. Okay, why the Wittig reagent is so important for the alkene synthesis, because you know that the for example I am going to write importance, why the Wittig reagent that is so important for the alkene synthesis, because you know that there are a lot of ways in which we can form alkene, but the Wittig reagent that is used for the preparation of the alkene, that would be difficult to prepare by any other reaction. So you have to say that is easy or that is used or easily used for the synthesis of alkene that would difficult to prepare by other reactions. Okay. For example, it is difficult to prepare like methyl cyclohexene, for example, from the, like you can say, we are going to take methyl cyclohexanol. Like if we use another ways, for example, we are going to treat with the sulfuric acid like as a dehydrating agent by the loss of water molecule. So it will not make methylene product. Okay, so actually here is the formation of, instead of methylene, there is the formation of like 1-methyl cyclohexene. Okay, like 1-methyl cyclohexene. So there is not formation of any methylene product. Okay, so now the question is, that is what about the definition and all the importance. Now the second one, formation of Wittig reagent, like how the Wittig reagent form. Formation of Wittig reagent. Okay, that is very important topic. So in the formation of Wittig reagent, as you know that the Wittig reagent is also known as ylide, as I already mentioned, that contain like the two opposite charge on its adjacent atoms. So normally the Wittig reagent, that is triphenyl along with the phosphorus, that is bonded with the CH2 group. Okay, while the CH2 group contain a negative charge and the phosphorus contain positive charge. Okay, so each charge atom has a complete octet here. Okay, and as you know that like sulfur, phosphorus can accumulate more than 8 valence electrons. So a phosphorus ylide can be converted into uncharged resonance structure. So that would be like that, pH3 P, pH3 pH3, and the negative charge that will be shifted here, so it will form like double bond with CH2. Okay, now the question is how the Wittig reagent form, or the formation of Wittig reagent. So first of all, you have to take the yield starting material in the Wittig synthesis is the preparation of the reaction of an alkyl halide. So we are going to treat with the alkyl halide. Normally I am going to take CH3Br. Okay, that is going to treat with the triphenylphosphine, so that is PH3P. Okay, so what happened here, the phosphorus that will attack, because you know that phosphorus has lone pair of electron, that will attack on the methyl group, while the bond that will shift it on bromine as a negative charge. So here it will form the next PH3 P CH3. Now the CH3 is bonded with the phosphorus, and now the phosphorus having the like positive charge on its surface. Okay, while the bromine that will be present as a negative ion. Okay, now the next one, that is also known as like phosphonium salt. Okay, or the another name, that is actually the name is methyl triphenyl phosphonium bromide. Okay, now they are going to treat a phosphonium salt that can be converted into conjugate base. So in this we are going to react that phosphonium salt with the butyl lithium, like PH3 P like I am going to write CH3 in this way, okay, and phosphorus contain positive charge. Now while the bromine is present here, okay, that is going to treat with the butyl lithium, and as you know that butyl lithium contain 1 2 3 along with the lithium, okay. So that is going to treat with the phosphonium salt. So what happened here, so like the butyl lithium that have ability to eliminate the hydrogen from here, and the bond will shift like that, okay. So it will form like you can say the bond will shift on the chlorine, sorry, CH2 on the CH2 group, okay. So that will form here PH3P contain positive charge, and now the CH2 group contain negative charge, okay, along with the now the hydrogen that will eliminate, that will taken by the like butyl lithium, so that will convert it into butane, because the lithium will like preferably bond with the bromine to make lithium bromide ion to, so that will make lithium bromide, and here is the formation of butane. So I am going to write here like along with the formation of butane and lithium bromide, okay. So now you can see here that is actually like triphenyl, like here the phosphorus contain positive charge and CH2 contain negative charge, so that is known as ylide, okay. So that is what, that is also known as Wittig reagent, okay. So that is our second step, in which here we have to form the Wittig reagent by using like alkyl halide and the triphenylphosphine, okay, along with the triphenylphosphine and alkyl halide along with butyl lithium we also used, okay. So now the next step is the mechanism of the Wittig alkene synthesis. So as I already discussed in the Wittig alkene synthesis, okay, in the Wittig alkene synthesis we have to use aldehyde or ketone. Let's suppose I am going to take like a ketone, okay, that is going to treat with the like ylide, so that is CH2 phosphorus PH3 like that, okay. Now how is it possible? So first of all, the negative charge carbon that will attack on the carbonyl group of the carbon atom, okay, because you know that the oxygen is more electronegative as compared to carbon, so there is a partial positive charge on its carbon atom, okay. And while the oxygen will preferably to make bond with the like you can say phosphorus, okay. I am going to show you here in this structure. Let's suppose I am going to make it another way, like carbon, oxygen, and I am going to write here CH2 along with phosphorus PH3, positive charge, negative charge, okay. So now the negative charge will attack on carbon, while the double bond will shift on the oxygen atom. Now the oxygen having the negative charge, so oxygen will preferably make bond with the phosphorus, okay, So there is an intermediate formation take place that is also known as tetrahedral intermediate, and that will look like okay. So that is known as oxaphosphatane. Okay, that intermediate is tetrahedral intermediate that is known as oxaphosphatane. Okay, so that is the first step in which we can say that like there is what happened. So there is like you can say cycloaddition reaction. Okay, here now the second step in which like you can say beta elimination. Okay, so there is the second step in which the beta elimination take place. Like when the beta elimination take place, let's suppose I am going to write again that intermediate carbon, oxygen, phosphorus, and here is pH 3. Okay, so beta intermediate elimination, or you can say beta elimination from the intermediate, that will take that will happen by the like exchange of the bonds or by the shifting of the bonds. So here you can say the oxygen bond like that will shift, look like this way. Okay, so there is a new formation take place in which you can see here now the carbon that is double bonded with the CH2 group, and along with that there is the formation of pH 3P that is going to double bond with the oxygen atom. Okay, so here you can say that is like alkene product. Okay, along with the alkene product there is another product normally that is known as triphenylphosphine oxide. Okay, so that is the general mechanism in which like the formation of alkene by using the Wittig reagent, and they are going to treat it with aldehyde or ketone. Okay, so these are the three like the main important subtopics in the Wittig alkene synthesis. First definition, then the formation of Wittig reagent, and then the mechanism. I hope you will understand our video and our lecture as well. So if you like our video, then kindly subscribe us and do share our channel. So thank you so much. We'll see you in the next video.